Global temperatures are rising with record heat waves almost every year, droughts affecting ever larger areas of our globe, and extreme weather conditions becoming more and more frequent. This is due to the skyrocketing, mainly man-made CO2 concentrations in our atmosphere. Now, it's high time that we clean up the mess that we made and use the climate gas to produce valuable materials at the same time. This is exactly what the new research initiative, Mining the Atmosphere, is aiming at. And we're here today to learn more about this ambitious endeavor by talking to two of the project leaders, Nathalie Casas, head of our research focus areas, Energy, Resources and Emission, and Peter Richner, Deputy Director of Empa, head of our research focus area, Built Environment. This is a special edition and a premiere today because it's the first time we have two guests here, and it's all the more a great pleasure to have both of you here on today's show, Nathalie and Peter.
Thank you.
My name is Michael Hackmann. I'm head of communications here at Empa, and I'm your host today. If those of you who tuned in regularly already know. For those who haven't had the chance to watch one of the previous episodes, heartfelt welcome. Bright Minds is a series of videos and live streams in which we showcase regularly some of our researchers and their smart ideas of a sustainable future. And since we're here live, I invite you all to submit questions in a comment section, and we'll answer them at the end of the episode. Back to today's guest, Nathalie and Peter. With Mining the Atmosphere, we want nothing less than transform the society and industry from a CO2 emitting society to a CO2 binding society. So net zero, which we haven't even achieved yet, is only a milestone on the way. It's not the final goal, Nathalie.
Yes, so even if we stop emitting CO2 today, we need to clean up the atmosphere. So we made a mess the last 100 years. We emitted far too much CO2 and we need to take it out.
Okay, so we take it out, we suck it in. Why not simply bury it underground in some of these old storage systems like the carbon capture and sequestration initiatives all suggest, Peter?
Well, this is certainly one way to go, and we will need this type of technology. The challenge of that is that we only have costs when we are doing that. There is no added value. And we are trying to find a way that we still harvest CO2 from the atmosphere, but convert it into products which create then an added value and which at least pay some of the costs that we have to
we'll
deal with.
Talk about costs later on, but very valuable comment. Let's stick to numbers. Calculations by the IPCC, the Intergovernmental Panel on Climate Change by the United Nations, they indicate that by the year 2050, we would need to have to capture 10 billion tons of CO2 every year. What would we ideally do with that?
Yes, so first I want to explain the number. So it's a really high number, and this is a number related to historic emission, but mainly to industries or emitters which are hard to abate, meaning that we can mitigate them hardly. So this is a huge number, and we need to take it out. What to do with it? We can store it underground, as discussed before, but we can try to make a valuable product out of it. So put it into the cycle, into the loop of our products.
Well, one product will probably not be enough because 10 billion tons of CO2, I mean, it's just massive. And you'll need a lot of energy and money. You hinted at that earlier. How would we make that work? How would that happen? Where would that come from?
The first question is, of course, about the energy. And I mean, we don't really have a lack of renewable energy on this planet. There is more than enough. There is sun, there is hydro, there is wind, there is geothermal. We just have so far not been able to make this potential really accessible to us. But this transition is happening now. We are going from a fossil energy system to a renewable energy system. This transformation will take maybe 2 or 3 more decades, but then we will reach a moment where we have only renewable energy and where we have places on this planet where we can really harvest renewable energy at extremely low prices. So we talk about 1 or 2 cents per kilowatt hour electricity, something like that. And once we are there, we can use this energy to harvest CO2, to convert it, and so on.
So basically, with your initiative, you're one or two steps ahead of time, sort of.
Yeah, but this is something which takes time,
Yeah.
and it's a whole system which has to change, and we all know to change a complete system is not something you do from
Overnight.
1 year to the next.
And the money?
As I said, we have to be honest with ourselves. We emitted CO2 for, say, 100, 150 years without paying for climate change and all those things. And now the time is coming where...
To settle the bill, so
yes,
to say.
Exactly.
Okay. Okay. Ahead of today's episode, we did a survey with online on social media with interested participants. We asked them about the idea, the concept of mining the atmosphere, how they like it. More than 50% said, "Wow, wonderful idea." About a third said, "Great idea, but does it really work?" And about 15% said, "It's probably not such a good idea." So there is a hell of a lot of support out there, but also some open questions. Now, where do you see the biggest obstacles, say, Peter?
I mean, what we try to do is to replace the whole fossil industry. And this is a huge industry. And the question is this possible? Are there any obstacles that we have not even seen yet? I mean, the vision we communicate here is really a very bright vision, and we cannot claim that we have all the details already thought through. So we will have to go through that. We have to create new value chains. It's going to be a global system in the end. And of course, there will be plenty of surprises. It could be that a certain material is missing, or that financially it's really too tricky. We will see.
Okay, so there will be deviations, there will be new routes, there will be turnbacks. And okay, great. Now let's go through the concept sort of step by step. The first step is, of course, capturing CO2 from the atmosphere, sort of hoovering it out, if you wish. How far are we, Nathalie?
Yeah, so today there are existing technologies which work. So it works, it's feasible. However, it's pretty expensive and it needs a lot of energy. So a lot of research needs to be done in order to make this technology more viable and easier to implement. And here at Empa, we are, for example, looking at filter material. So the material who does the job. We need material which does it better, faster, and cheaper.
So basically you pump through ambient air, CO2 gets selectively absorbed by these materials, and the rest sort of just goes through, and then you desorb the CO2.
Exactly.
That's the idea. Okay. Now, next step, we've got the CO2 somewhere in a big tank. Chemical conversion. So you have to convert CO2 into some other C-containing materials. What do you have in mind there?
Exactly. So if you think of our economy, most materials are made of C. So we really have a carbon-based economy. And we can transform it in various steps to different products. So the easiest one is to add hydrogen and create methane, which then can be burned or pyrolyzed to get energy and carbon. So that's something we do at Empa, and where we investigate how to do this better, easier, cheaper.
Let's pick up that point. So you basically convert CO2 into CH4, methane, biogenic methane, or natural methane, if you wish. Then burning that again, we could generate electricity or use it as a fuel. Synfuels is kind of this idea.
No, but actually we don't want to burn it. We do this pyrolysis, so this is a thermal process without oxygen. This leads to hydrogen. The hydrogen we can use for high temperature applications. We can use it as a fuel for a gas power station, etc. And we get carbon. And the climate problem is related to carbon, not to the oxygen in the CO2.
Right.
It's really about the carbon atom. And by generating carbon, this also means we have the highest density of carbon, and we get the solid instead of having CO2 as a gas, which is much more complicated to deal with. And so we have this solid. And from there, we try to develop basically mostly construction products.
That's a good keyword, construction products. There is something in front of you, and we'll see some video footage right now. This is a carbon negative or a CO2 negative concrete. How did you produce that?
Well, what you see is we produce those I would say, pellets made out of carbon, and we replace with that some of the aggregates in the concrete. This means also that this carbon is stored for centuries or millennia in this material. It cannot go back to the cycle, which is very important. And concrete, we use about 30 billion tons per year globally. And we have been talking about the 10 billion tons
yes.
of CO2. So
Yes.
you see, we are in the right dimension. The construction sector is the only sector which can absorb materials at the level which is relevant when we talk about mining the atmosphere. And that's why we go there. And the concrete that we have here actually is already quite good. This is a standard concrete that you would use when you build buildings.
And the black
The black
dots
stuff
say that is basically
This is carbon.
CO2, so to speak.
Exactly.
Okay, so
And
CO2 goes into
yeah.
my house.
Yeah,
Yeah.
it becomes
Okay.
a sink for
Yeah.
CO2.
Okay. What other materials? So construction, yes.
Yeah.
Big mass. What other materials?
Of course, one can also think about high-value materials where you have much less in mass, but it generates a lot of value. And as Nathalie said, a lot of our economy is based on carbon materials. Could be carbon fibers, but also polymers, etc.
Yeah. Okay. Lots of different industries. You hinted at the fact that the petro industry has to go through a huge transformation. You can't do that, just the two of you. So I'm pretty sure that you need some partners in crime there. Who do you think of teaming up with, and what is the reaction out there?
Definitely. So I think that the problem is huge, and we need to transform the whole industry. So industry needs to be involved.
Mm-hmm.
We need research to make things better, but we need the industry to bring it into the society, into our industry.
And to actually produce the products.
To produce the products.
Yeah.
And depending on the product, we are teaming up with different industries. So it starts with the, let's say, the industry producing methanol as an example. So we need partners who have this process already today in their portfolio, which transfer it to a more sustainable process.
Okay. Now, if one looks ahead, say 10, 15, well, I don't know, a couple of years, what would you think is the first kind of mass product that is truly CO2 negative, or that is truly sort of containing X CO2 molecule?
Well, for us at Empa, clearly, this is the goal. Concrete has to be the first one. It's the most important one and the one which can have the biggest impact. And I mean, we're here in the Nest building. We plan to have within 2 years or something like that, the first unit that we build using CO2 negative materials and showing that, yes, buildings can become a sink for CO2. And then until it's on the market, this concrete is produced in a very standardized way. The only thing is you just add this carbon to it. You don't have to change
other
stones.
Yeah.
So you don't have to invest anything in process technology regarding concrete, which means that let's say the obstacle to bring it into the market is quite low. And therefore, I think within 5 years, we should have products like that on the market, the latest.
Okay, and the unit you mentioned is termed Beyond Zero.
Yeah.
That is basically sort of already hinting at, the program behind it. It goes past the net zero idea. When will that come about, roughly?
2 or 3 years from now.
Okay, wonderful. Looking ahead. Looking forward to that. That was it for today. Now we have to take, or we can take, a couple of questions from the audience. For the first time, we asked ahead of time, and we got some questions in there. Now, there's the first one. Anthony is asking, the idea behind mining the atmosphere is great. Well, that's one of the 53% or 85%. But won't the costs, won't the costs exceed the added value, cost-benefit relationship?
Probably yes, but as I said, we are doing a cleaning job, and that's always costly, and we just can reduce the cost in the end. with having added values. And what is very important, we didn't mention before, but the process we propose also includes the import of renewable energy from places where there is plenty into Switzerland, for example, in winter. And that might actually be one of the drivers which really make it not so costly anymore, because we will have to find sources for renewable energy.
Well, there was that's not a question here. There was a study issued this week in Switzerland where they said that, doing nothing at the end of the day might even sort of raise the price tag even higher.
Yes, I think we need to think about to which costs we compare. And
Yeah,
if
exactly.
we do nothing about the environment, the cost will be skyrocketing.
Okay, so it won't be zero.
It won't be zero. I think it depends where you set the boundaries. But if we imagine that some big cities are underwater, we have huge flows of immigration all around the globe, creating a lot of costs, right? So we really need to look into the mirror and say, what are we comparing it to?
And we're probably also losing a lot of land, useful land, agricultural land, urban land. You said San Francisco. I mean, a lot of cities are really been on the waterfront. And thank you. Next question. Actually, various people asked that. So no name attached to it. Would it make more sense, or wouldn't it make more sense to use natural machines, quote unquote, like trees, plankton, plants, instead of artificial ones to actually do the capturing job? Photosynthesis, of course, is the principle behind it.
Yes. No, I think plants are doing a great job. So we need plants.
Thanks to plants.
Yeah, thank you, plants. And we need many of them. Yeah. However, tech has an edge here. Okay. If you look at the footprint, and let's talk about carbon capture only, it's about 1,000 times more efficient than a plant.
Okay,
or a tree.
Okay. By mass or by whatever,
footprint by square meter.
Okay.
So
per square meter.
Yeah, okay. If you put let's say a capture unit on a given space, it's 1,000 times more efficient than trees on the same space.
Okay, so you would save a lot of land.
We save a lot of land. So we used tech to blow all the CO2 out. We will need tech to get it in again.
Well, that's a perfect logic in a way. Yeah. Thank you. Next question, Abdel Kabir Lansari. I'd like to propose the following idea. Quote, instead of capturing CO2 in the atmosphere, very dilute, of course, only a couple of 400 ppm, I guess, right now. Wouldn't it be better to place the collectors, the hoovers, at a factory chimney, at a point source, and pipe the CO2 directly to the units where the gas will be processed, like chemically converted and so forth? That would be right. That could be right next to the factory. So you do it all on the spot.
We have to do that to reach net zero. By that, we can actually reduce the emissions that we have today. If you have a cement plant, you capture the CO2 at the chimney, that's good. But that doesn't solve the problem of the emissions of the last 150 years.
That is
because that's already in the atmosphere, and this is what we have to take back in addition. So point sources are collection at point sources are mainly targeting reaching net zero. But if you want to go negative, you have to go to the atmosphere.
The stuff that is already out there and has been blown out, I don't know, 50 years ago, 100 years ago. Okay. Sorry. Next question by Oliver. When can we actually see this transition from a CO2 emitting to a CO2 binding society happening? Kind of a tricky question because this is a transition. So this is a process. You can't really say when does the process happen? When does it start?
Well, we already started, and the goal that we still work very hard for is to reach net zero by 2050. So we go down and then we should go into the negative. But one has to realize already to get to zero, we need negative emissions. So already in 2050, at the net zero state, negative emissions are part of the system.
Of the balance, basically.
But after that, they will become much more important. So it's a gradual growth, and we are starting this.
Okay. And 2050 is kind of the energy transition sort of deadline, if you wish. Celine, what can I, as an individual, do to contribute to this change? Well, that's a very personal question, but I think a lot of people might be interested. Nathalie?
Yeah, so I think we need the help of everybody to make this happen. And personally, one can look at the emissions one or as an individual produces and see where can I do something to reduce. And
so your individual footprint, so to say.
Exactly. And there are many measures. So you can consume less, you can travel less, you can eat a diet which is less CO2 emitting. So there are many, many handles, and depending on each individual, one is easier to do than another thing. And I think we really need everybody's help here.
So it's a societal task, if you wish. Next question, Matthias. We've got a lot of questions today. I'm very glad about that. Matthias, the VCAT group from France has introduced the Carat cement, also by adding charcoal. However, the cement and not it is cement and not concrete. The cement is carbon negative. What do you think of that? That would probably be something like that.
Yeah, there are different research projects going on to replace the so-called Portland cement, which has this high CO2 footprint. Also, we work at Empa on systems like that based on magnesium. And the nice thing here with the carbon pellets is you can combine that with every type of binder. If the binder, the cement by itself is already CO2 negative, it's even better. So it's not something against the other, it's just a complement, and we have to mobilize everything that we can.
So one goes into the recipe of the cement as such, sort of reducing the inherent CO2 emissions of the cement, and this actually goes into the concrete formulation by adding CO2 from the atmosphere.
Exactly.
Next question from Sabrina. I have a question about biogenic CO2 emissions. Isn't it the case that biogenic emissions in concrete cannot be considered as a sink because there is no guarantee that they will be released again at the end of the service life?
Yeah, I mean, climate scientists say that in order to claim a process to be CO2 negative, you have to guarantee 1,000 years plus that the CO2 is out of the
storage,
cycle.
So to say.
Exactly.
Yes.
And again, this is one of the reasons why we go for concrete. What we think here, we can recycle this concrete probably 3 times or something like that. So then we already have maybe 200, 250 years. And then eventually it will be crushed and it will be an inorganic material which goes into a landfill, which is completely inert, and it stays there.
So it won't be decomposed like biomaterial?
Because it's embedded in this concrete material.
Okay. Next question from C3. Does this kind of technology already have the necessary investments? So is there people out there, I rephrase it a bit, who are willing to bet on these kind of technologies? I assume private money and not public funds.
Yeah, so if you think about the individual steps, talking about CO2 capture, specifically DAC, there are a huge amount of venture capital and investor money going into this technology. I think people have realized that this is really necessary, and there's also big money flows going into it.
Okay, so it's not a lack of VC that sort of hinders you?
No, I think
at this point in time.
At this point in time, not. I think to scale it up, really big amounts of capital are needed. And there it's where the tricky part comes. So we are talking about 1 billion per plant. So it's a huge amount of money.
Okay, well, that's not cheap, as you said earlier. Next question by Matt. What about the characteristics of the concrete which included carbon? Is it as stable and resistant to erosion, etc.? I mean, material properties as regular concrete, or does it currently still have restrictions in its use?
It's what we call the C30 concrete. So as I said, this is a pretty standard concrete that you use for standard applications like buildings. I would not build a highway bridge with this at the moment. But most of the other applications, we believe this is possible. We still have to work on things like recyclability, etc. We have to prove all those things. But we are really in line with the mechanical properties of standard concrete.
And you looked at it.
We keep on working on those things.
Okay. Question by XL. How would you compare the conversion, talking about chemical conversion now, of CO2 to methane that we sort of talked about, with its conversion to methanol? sort of pros and cons, I assume? Or what's the better way? What's the more versatile way?
Yeah, I would look at it from the use part
Point
of
of view.
it. And if we talk about methane and also methanol, we have an infrastructure already in place. If we talk about the energy or energy contained in this two species, it's different.
Mhm.
So depending on the use, so methanol can be used as a platform chemical, methane cannot.
Mhm.
So from my point of view, we will need a mix of both. I cannot say this is better than that,
Okay.
but depending on the use,
Yeah.
one or the other
Is
better.
the process of choice,
Yeah,
so to say. So
correct.
methanol being more the more versatile route if you wanted to go into sort of
Polymers.
replacing petrochemistry by atmochemistry, whatever you want to
Exactly.
call it. Okay, question by Daniel. Is Empa also researching the production of fertilizers / plastics from carbon taken from the air? Well, two different products. Fertilizers, not
really,
my
no,
no-
no,
not
this
to
is
my
not
knowledge.
really.
Plastics is polymers, of course. That's
Yep.
what we sort of hinted at when we were talking about the methanol route. Are we had a research call just recently, sort of kicking off numerous projects in these veins. Is there one amongst it going
Yeah,
into
which
the
goes
polymer?
into the polymers. Yeah, yeah,
Okay,
of course.
so the answer is yes, we do that. We will start that. So that was it. If there's any more questions that we haven't answered so far, don't worry, we will answer them online. All the answers will be available online on our social media channels and after the live stream. This is the end of the episode. The last task. Thank you very much, my two guests, Peter, Nathalie. It was a real pleasure, and the interest, the sheer number of questions was really flabbergasting. The most questions we have received so far. If that was a bit too fast, the second to last issue of our research magazine, Empa Quarterly, actually, you've got a lot of stories about mining the atmosphere. You can subscribe to that free of charge. Please do so. And there is another thing. We have a technology briefing coming up on the 26th of June to the topic of mining the atmosphere. I'll hope you'll tune in again next time. We'll post the exact date and the topic on our social media channels. And I'm looking forward to seeing as many as possible of you there. Thank you very much.